Hello, my dear students. Actually, we are moving into the last part of the last chapter. Okay, so after discussing the regression analysis, in syllabus there is a concept called R square or goodness of fit or coefficient of determination. Okay, so today in this video, I'll discuss with you what is this goodness of fit or what is this R square or basically what is this uh, coefficient of determination. Okay, so the coefficient of determination is basically a summary measure that measure how well the data fit the regression line or how the regression line is good or bad, or whether the regression line depicts the exact whether the regression line will fit the actual data, or whether the regression line is good or bad, or the result that we have got from this regression is good or bad. Okay, so goodness of fit is basically a commonly used summary measure, okay, that tell us whether the regression result is good or bad. Okay, and it basically tells us whether the sample regression line, how well the sample regression line fit of a regression line. Okay, so how the your sample regression line fit your actual sample data. Okay, so in regression model there will be a dependent variable and independent variable. What is the aim of this model, or what is the aim of the regression? Predict the changes in the dependent variable on the basis of changes in the independent variables. Okay, so regression, our aim is to tell us or tell how much dependent variable will change when there is a changes in your independent variables. Okay, so basically the changes in dependent variable means what? It is basically the variations in your dependent variable, okay, or it is sigma yi minus y bar square. Okay, so variation means what? The changes of a variable from its average, y minus y bar. Okay, then total variations means what? Summation of yi minus or y minus y bar square. Okay, so the total changes in a dependent variable can be expressed as a sum of two components. First component is the changes that can be explained by the regression line, and second one the changes that cannot be explained by the regression line. Okay, so in regression model y is equal to a plus bx plus u. Okay, in this there are three different parts. First one dependent variable, second one independent variable, and third one is the other variable that we have omitted from the model, u variable. Okay, and total changes in y may be based on, depends on changes in x plus changes in other factors. Okay, so this changes in x means what? The variations that can be explained by the estimated regression model, and this changes in u means what? Actually it is changes that cannot be explained by the regression model or the regression coefficients. Okay, so total variations in y can be separated into two. One is variations that can be explained by the regression line. Second one, the coefficient, the variation that cannot be explained by the regression line. Okay, and the variations that can be explained by the regression line is called ESS. Okay, ESS, explain sum square. Okay, then variation that cannot be explained by is called RSS. residual sum square. If you add these two things, you will get what is called total sum square. Okay, so ESS plus RSS is equal to TSS. Total changes, that means total sum square is equal to estimated sum square or explained sum square plus residual sum square. Okay, then what is the total portion of this which is explained by your regression line? It will be ESS divided by TSS. Okay, what is ESS? ESS means sigma y cap minus y bar square. What is TSS? It is sigma y minus y bar square. Okay, so if you find sigma y cap minus y bar square and divide with sigma yi minus y bar square, you will get the value of r square. Okay, or you can use 1 minus sigma u cap square divided by sigma yi minus y bar square, or 1 minus r divided by TSS. Okay, so r square is equal to ESS divided by TSS, or 1 minus RSS divided by TSS. What is this RSS? Residual sum square. TSS, total sum square. Then ESS is explained sum square. Okay, yes. So for example, the total changes in a variable is expressed as 100. Okay, then 80 is explained by X, 20 is not explained by X. Okay, then what is the portion of total variation that can be explained by X? It is 80 divided by 100, 0.8, or it is 1 minus 20 divided by 100, that's also 0.8. Okay, so this is what we called R square. Okay, and the R square is basically the square of the correlation. R means correlation, then R square means correlation square. Okay, and it is non-negative quantity and it will never become negatives. R square will never become negatives. Okay, and if the R square value will always lies in between 0 and 1. Okay, so if it is 0, what means? Any of the changes in dependent variable are not explained by X. 0% changes in X and Y are explained by X. That means nothing is explained by your X. 1 means what? Total 100% changes in your dependent variable can be explained by the X. Okay, so these are all the properties of R square. Now let me find out how we can find out this value of R square. Okay, for that let me to take the example that we have found yesterday. Okay, so assume that we have Y and X. What will be our model? Our model is equal to Y is equal to A plus Bx plus Q. Y is equal to A plus Bx Q. Okay, then what is B and what is A? That we can find. Okay, so for that what you have to do first, you have to find out the average. Okay, so I found the average of Y, it is 1.115, and the average of X is equal to 170. Okay, then I have found small y and small x. So small y is nothing but the deviations of y from y bar, and x is also deviation of x values from x bar. Okay, then what we have to do? We have to find out y into x, then x square. Okay, so yx is equal to, this is the y, this is the x. Okay, if you do it for all and if sum it, 18,040, and x square is equal to, this is the x, and if you square it, this is around 33,000. Okay, then what is the value of b? Is equal to this divided by the sigma yx divided by sigma xy square. 0.573, and A is equal to what? Y bar minus beta cap into X bar, 17.4303. Okay, yes. Now, what is this TSS? TSS is equal to ESS plus RSS. This is the equality. Total changes in this dependent variable can be explained by this 80, and some of this cannot be explained by X. Okay. So what is TSS? TSS is nothing but sigma y minus y bar square. Sigma y minus y bar square. Okay, so how we can find out y minus y bar? This is the y minus y bar. Then if you square it, then small y square. Okay, y minus y bar is equal to small y. Then small y square is equal to TSS summation. C equal to, this is the small y. If you square it, you will get, oh my god, this is y, you square it. Okay, and then if you do it for all, and if you sum it, yes, 11,954. Okay, so TSS is equal to 11,954. Then what is ESS? ESS is nothing but, okay, sigma y cap minus y bar square. Okay, for that you have to find out y cap first. Okay, so what is y cap? Y cap is equal to, this is A plus this is B into this is X. Okay, it is 63 point something. Okay, yes. Then if you do it for all, you have got y cap. Okay, then if you find out the average of y cap, you will get the same average of y. So average of yi and average of y cap will be the same. Okay, then y cap, now you find out the y minus y cap, so it will be small y cap. Here, this is the y cap minus this is the y cap bar or y bar. Okay, see, this is okay. Wait, minus this. Okay, 51 point something. If you do it for all, you will get small y cap. Okay, then what you have to do? Small y cap square. This is 51 is 51 is equal to this 1 square. You do it for all and sum it, you will get 18,000 something. Okay, it is 10,870.41. So TSS is equal to 11,954, ESS is equal to 10,870. Okay, now what you can find out u cap square. Okay, u cap square means what? This is actual y. Okay, this is your Just wait. Okay, sorry. Okay, so which is equal to, this is your y minus this is your y cap. Okay, then you just square it. Okay, and do it for all and you sum it, you will get RSS is equal to 1830.58. Okay, yes. Now we can find out the R square. R square is equal to what? ESS divided by TSS, 0.90 something. What does it mean? 90% of the total changes in Y is explained by the X, and 10% of the variations in Y cannot be explained by X. Okay, and you will get a similar value when you use the other equation. What is that? 1 minus RSS divided by TSS. You will get the same result. Okay, so this is all about R square or goodness of fit or coefficient of determination. It is basically nothing but the correlation square. Okay, then if you find out a correlation between these two, correlation, okay, between, this is the first set of value and this is the second set of values, what you will get? 0.9536. okay, then 0.9536 you square it, you will get the R square. Okay, so R square is nothing but the goodness of fit, and it will tell us how well the sample regression fit the regression line. Okay, yes. So that's all about today's session, and tomorrow onwards we will start the chapters in mathematics. Okay, thank you.